that the acceleration is proportional to the what? Or inversely proportional to the mass. So if I look at this thing, I know that from Newton's second law, we say that the acceleration is equal to the net force divided by the mass. So what am I going to do? This time, I'm going to ignore this. So this means that the force must be equal, or forces must be equal. So what am I going to do? I'm going to focus on the mass. Okay, so what am I saying here? What I'm saying here is that if I say an object is a massive object, we typically associate with a heavier object. We got to be careful with that. Mass and weight are not the same thing, but that's what a lot of people do. And if I have a less massive object, then a lot of the times we associate a lighter object. So what we're going to do with this case here is that when I write that A is proportional to 1 over the mass, what that means here is that if one pushes, with the same force on two objects, of different masses, the more massive object is harder to accelerate. And so this guy right here is, by definition, the law of inertia. And okay, so this is the law of inertia. Again, if you've had physics before, they would have said that this is Newton's first law. Mass is not introduced till the second law. So picture-wise, what does this mean? So let's draw it out. So I have to apply the same force on two different objects. So let's go draw that. So I imagine that I have this object. Okay, so if I have this object, I know that this guy has a big mass. And then I need a second object. So the second object is going to look like this. So when I look at this guy has a smaller mass. So now what am I going to do? I'm going to push on these guys. And what I'm going to do here is I got to apply the exact same force. So you could imagine that I'm going to apply this force that's this big, and then this force that's that big. So they're exactly the same force. I mean, you already know what's going to happen. If I have a larger mass, yeah, it's going to be harder to move. And this is exactly what Newton's second law says. It's common sense that this guy is going to be harder to speed up. This guy is going to be easier to speed up. So when I look at this thing, we say that the larger the mass, how about it says the larger the mass, the smaller the acceleration. Maybe I should have put an arrow here. Whereas if I have the smaller the mass, the higher or the larger or higher acceleration. And so picture-wise, our equation says if I have a bigger mass, I have a smaller acceleration. If I have a smaller mass, I have a higher acceleration. So let's keep moving along this law of inertia, and I think it's worth thinking about here. And we should start here with this question. What is mass? What is mass? And what we should say here is that mass is how much stuff an object has. Okay, so mass is how much stuff is inside an object. So when I say how much stuff, I really say the amount of matter. So I have a pretty good demo that I could show you if we were in the classroom, and this is sort of like an example to get my point across here. So what we have here is that we have two tennis balls. And what you see here is that in this tennis ball, what you find here is that the inside of this guy it's an air-filled tennis ball. And then I have a second tennis ball. And the big difference between these two tennis balls, you can't tell the difference until you actually handle it. I drilled a hole into the tennis ball, and then I filled it with lead shot. So this guy is filled with lead shot. So it's a lot heavier. There's a lot more mass. There's more stuff in there. But what do we say here? We say that this guy has less stuff inside, and that means less mass. This guy over here has more stuff inside, and therefore this has more mass. So that's a very, very simple way of trying to define what mass is. But believe it or not, that's not the definition of mass. What is the more precise way to define mass? It was Newton that showed us that. Okay, and it goes something like this. Okay, here is a more precise definition of mass. In fact, there's a name for this mass. It's called inertial mass. So what we want to do here is that we need to look at the motion of objects. We need Newton's second law. And here's what we find. So imagine that we have two objects. And what I'm going to do here is that in one, I have a bicycle. Let's say that here's the wheels, and then here's a bike. And what we're going to do here on this bike here is that we're going to apply a force. And what we do here is that we're going to apply the exact same force. And so compared to what? A truck. Now let's say that this is a truck here. So when I look at this truck here, I'm also going to apply the exact same force on this massive truck. Now, when I look at this thing, it looks like I'm saying the exact same thing, but I'm really not. So the law of inertia says this. So less mass, we said higher acceleration. And again, what did we write? We said a little mass gives us a high acceleration. Then we said more mass implies a lower acceleration. So when I look at this guy, I mean this. So this is sort of a repeat of what we just said. Now, here is the difference. The most common way to actually say that is that this has less resistance to changes in motion. If you find that it's really easy to accelerate, then we say that it has less resistance. Therefore, its mass is lower. On the other hand, if it has more resistance to change its state of motion, then we say here that it's harder to accelerate, and that's because the mass is bigger. And so